In the last video we looked at distance time graphs, which show us how the distance of an object varies over time. In today's video though, we're going to focus on velocity time graphs, which show us how an object's velocity changes over time. These graphs both look pretty similar, and it's really easy in exam to get the two of them confused. So just be really careful and double check which one you're looking at. As these graphs have velocity on the y-axis and time on the x-axis, if we want to find the gradient of the curve at any point, we have to do the change in velocity over the change in time, which you might notice is the formula for acceleration. So on a velocity time graph, the gradient tells you the acceleration. This means that if the curve has a constant positive gradient, like it does in this first section, then it must be experiencing a constant acceleration. Whereas if the curve has a constant negative gradient, like in the last section, then there must be constant deceleration. We can calculate the acceleration or deceleration by plugging the relevant numbers into our equation. For example, in this first section, the change in velocity is 3 meters per second, and the change in time is 2 seconds. So the acceleration would just be 3 divided by 2, so 1.5 meters per second squared. Now, flat sections of the curve have a gradient of 0, and so aren't accelerating at all, which means that their velocity is constant, because it's not increasing or decreasing. So to find the velocity during these stages, all we have to do is look at the y-axis. So in this second stage, the velocity would be 3 meters per second, and in this fourth stage, it would be 5 meters per second. If the curve gets steeper, like in this third stage, the gradient must be increasing, and so this means that the rate of acceleration is increasing as well. The last thing we need to look at is how to find the distance that was travelled. For this, we need to find the area under the curve. So if we wanted to find the distance travelled in the first 4 seconds, we'd be interested in this area. And to make it easier to calculate, we could split the area up into a triangle on the left and a rectangle. The formula for the area of a triangle is 1/2 base times height. So in this case, that would be 0.5 times 2, which is our time, times 3, which is the velocity. So together, that gives us 3 meters. Then to calculate the area of the rectangle, we have to do base times height. So just 2 times 3, which is 6 meters. So the total area, and thus the total distance travelled during these first 4 seconds, would be 3 plus 6, so 9 meters. One of the odd things to be aware of here is that even though area is usually given in meters squared, because we're finding the distance travelled, we just leave the answer in meters. It's just one of those odd things you have to accept. Now, calculating the area under curved parts of the graph is a bit trickier. And if you only have to estimate it, then you'll be given a grid as the graph background, like this. And you can find the area by counting the number of squares under that section of graph. For example, in this graph, each square in the grid is equal to 1 meter of distance travelled. So for our curved section, we've got 6 full squares, 1 square that's nearly full, and these other 2 that are almost half full. For these partially full ones, you want to try and combine them to make a full square. So here we can count these 2 halves as 1 whole. And then if we add up all of our blue squares together, we've got a total of almost 8 squares, which means that the total distance travelled over these 2 seconds would be around 8 meters. Anyway, that's everything for this video. So if you enjoyed it, then please do tell your friends and your teachers about us. and we'll see you next time.